So let's take a look at another example here. It says, you will create a confidence interval using StatCrunch and investigate what happens to a confidence interval, the margin of error, when the level of confidence increases and all other summary statistics stay the same. So it says, according to pewresearch.org, a 2014 survey found that 32.1% of adults aged 18 to 34 were living with their parents. Suppose that this was based on a random sample of 1,200 adults in this age group. So let's first check that the conditions for the central limit theorem apply. So first, did they say that it was a random survey? They did, yeah, it's a random survey. So we can assume that we're looking at a random and independent sample. The proportion of successes, if we're looking at a sample of 1,200 people, and my p-hat value is this number right here, the percentage. So the expected number of successes would be 1,200 times the 32%. Whatever that number is, I don't have a calculator with me, but it's certainly more than 10. And then, of course, the expected number of failures would be the same thing. It would be the complement of that. And again, that's going to certainly be more than 10. So our sample is large enough. And then the population is certainly large enough. The population would need to be at least 10 times the sample size. And of course it is if we're talking about all American adults. Let's see. Adults in this age group, 18 to 34 is the age group. So yeah, all adults in that age group should certainly be more than 10 times the sample size. So it says using StatCrunch, find confidence intervals using 80, 90, 95, and 99%, and report your information down below. So I can't show you StatCrunch using the format I'm working with to record these videos, but I do want you to pay close attention to these directions, since this is really important. You're going to go to the Stat menu, and then you're going to find Proportion Statistics, and then choose one sample and with summary. And then it's going to ask you for some different pieces of information. So X is the number of successes. It's got to be a whole number. So in this example, they gave you a percentage, 32.1%. We're going to need the number of successes that goes with that. N is the total number of observations. So observations, of course, would be your sample size. And then select confidence interval for P, and then enter whatever confidence level they're asking you for, and click on compute. So I'm going to just go ahead and give you the numbers. In all three cases, in all of these cases, our sample proportion doesn't change. So remember, our sample proportion from the problem was this 32.1% number. I'm going to put it in here as a decimal, so 0.321, and then I'm going to just put that in for all of these. So in every case, the sample proportion stays the same. That never changes. All right. Our lower limit then, when we put in an 80% confidence interval, is 0.304, and the upper limit for that one is 0.338. Again, I'm getting this from StatCrunch. The standard error that goes along with this is 0.0135. Now the standard error, remember, is based on p-hat, which doesn't change, and n, which doesn't change. So the standard error for all of these is going to remain the same. That's that estimated standard error formula using the square root formula. All right, and then let's look at the limits though. So for the lower limit and the upper limit for an 80% confidence interval, the width of the interval is 0.034. How am I getting that? I'm literally taking the difference from the upper limit minus the lower limit. All right, and then for a 90% confidence interval, so from StatCrunch, the numbers would be 0.299 for the lower limit and 0.343 for the upper limit. So if I take the difference between those two, I'm getting a width now of 0.044. For a 95% confidence interval from StatCrunch, my lower limit is 0.294. My upper limit is 0.347. So if I take the difference between those two numbers, I'm getting 0.053. And then finally for the 99% confidence interval from StatCrunch, my lower limit is 0.286 and my upper limit is 0.356. So if we take the difference between those to get the width of our confidence interval, for that one I'm getting 0.07. So I hope you're noticing a pattern here with the width of the interval. As the confidence level increases, everything else stays the same, assuming the sample size and everything stays the same, the width also increases, and that's the takeaway here. So it says what happened to the confidence level, what happened to the confidence interval as the level of confidence increased. so it gets wider. That's the most important thing to observe. So it gets wider. So as the level of confidence goes up, so too does the width of the interval. Is it plausible then to conclude that the true percentage of adults living in this age group with their parents is 38%? So what you want to think about is what was our cutoff for something that's unusual or unexpected or outside of the ordinary? And if you'll remember that 2 standard errors or 2 standard deviations when we looked at a normal distribution was our cutoff. So for us, that would be the 95% confidence interval. So notice the 95% confidence interval, where does it range from? It ranged from about 29.4% to about 34.7%. Well, what do you notice then about 38%? It's certainly outside of that interval. So for that reason, we're going to say no, it is not plausible, because this 38% is outside of our 95%, I'm going to abbreviate, confidence interval. And that's what we're going to look for when we talk about plausible values. So key point here, as the confidence level increases, the width of the confidence interval will also increase. Let's look at another example. So a political consultant randomly surveys 500 voters in a district to see how many intend to vote for a certain candidate. Of the 500 voters surveyed, 265 indicate that they will vote for the candidate. Using a 99% confidence interval, should the consultant predict that the candidate will win the election? He must win a simple majority of the votes. So first, let's verify the conditions of the central limit theorem. So they told us that the survey was done randomly. I believe they said that. Randomly surveys. Yep, right there. So random and independent is met. The sample was 500 voters. So we know, and actually the number of successes, if successes is voting for the candidate, we actually know what the number of successes are. The number of successes is the 265 who said yes, they would vote for the candidate. And that's certainly more than 10. So I don't have to do n times p hat, because that would be a little bit redundant here. P hat would be 265 out of the 500, but I know what the successes it's going to be. It's the number who are going to vote for the candidate, which is 265. So then the number of failures would be the complement of that event. And so if we think about it in terms of number of voters, how would we get that? It would be the ones who aren't going to vote for the candidate. So that would be 500 minus the 265, which gives me 235 who said no. That is also greater than 10. So we are large enough for our sample size. And I assume the population is large enough to expect more than 10 times 500 people in it. Most districts probably would be for a political district. And our p hat, by the way, just so we have it ready, is the 265 divided by 500. And that gives us about 53% of the vote. So construct our 99% confidence interval. So how do we do this by hand? Well, remember that our confidence interval is found by taking p hat plus or minus the margin of error. But remember, the margin of error was, well, here, let's write that. The margin of error, and that would be p hat plus or minus z star times the standard error. So first I need to know what z star is. So z star, if I'm using a 99% confidence interval, that's how we decide which z star to use. Let me go back to the table we had earlier in the previous video. And I erased it, but I have it in my notes here. Let's see, for a 99% confidence interval, you should still have this. Your z star value for a 99% confidence interval was 2.58. And so that's what we're going to go with for our construction of our confidence interval. So the z star value that I'm going to use is 2.58. I need to also calculate the standard error. So my standard error is going to be the square root, standard error estimated, it's going to be the square root of p hat times 1 minus p hat all over 500. And that gets me a value of about 0.0223. So my margin of error then is going to be z star times the standard error. If we put all this together, here, let me go ahead and write it down here. So margin of error is going to be z star times the standard error, which is the 2.58 number, times 0.0223. And that gives me a margin of error then of 0.0575. So how are we going to get our confidence interval? We're going to take p hat and we're going to add and subtract that margin of error. So p hat was 0.53, don't forget, plus and minus our margin of error, 0.0575. And so my lower bound, if I subtract it, I'm getting a lower bound of 0.473, and my upper bound would be 0.588. So let's summarize what we found. So we would say we are 99% confident that between, and I always like to write these as percentages, although you'll see in the homework sometimes they ask you to write them as a decimal. It just depends on the question. That between 47.3% and 58.8% of voters will support the candidate. Now the question also said, should the political consultant predict that we're going to have a win? And I would say based on our confidence interval, no. So do not predict a win. And the reason I say that is because part of our interval falls below 50%. So do not predict a win since interval includes values or falls below 50%, because my lower bound went all the way down to 47.3%. So I would say based on that, we should not predict a win. He might win, but there's a good chance he might not. All right, I've got one more example here. So according to housingwire.com, 93.8% of homeowners had positive equity in their homes. Suppose that the margin of sampling error is plus or minus 3 percentage points with a confidence level of 95%. So our margin of error is 3%. They've actually done the work for us, really. We don't have to do, we don't have to figure out what the margin of error is and find the z-star value and the standard error. That's the margin of error. It's 3%, and they've given that to us. So they've actually done most of the work for us. It says state the confidence interval in interval form. So our p hat, according to them, was, we're going to assume this is from a sample of homeowners. So our p hat was 93.8%, and our margin of error is 3%. So p hat plus minus the margin of error gives me a lower bound of 90.8% and an upper bound of 96.8%. So I'm literally taking that margin of error and I'm adding and subtracting it to the p hat value. How would we interpret this? We could say we are 95% confident that this method, so that between 90.8% and 96.8% of homeowners, the true population proportion of homeowners with positive equity is between those two numbers. So if homeowners have positive equity.